All right. Good day, everyone. I want to welcome you back to this channel. Um, we'll be discussing this question that you have on your screen. The question says that which of the following is not a prime number? And these numbers we have 13, 16, and 17. So, but I think it's proper for us to know what a prime number is first before laying hands on the question. So, let's get what a prime number is. What's a prime number? So as you can see on your screen, the prime number has two factors, itself and 1. That is, a prime number can only be exactly divided by two factors, only two factors, which is 1 and that number itself. So we can have some example here. I have them on the screen: 2, 3, 5, 7, 11, and so on. So these are prime numbers. And I want you to also note that 1 is not a prime number. So I will leave you to find out to the reason why 1 is not a prime number. So I want you to find out by yourself. And we are going to demonstrate what a prime number is using some examples. And that example is the question that you saw earlier on. So let's go straight to that one. So, like we have the first question that we are laying hands on is 13. So, we want to confirm if 13 is a prime number or it's not. Okay, so let's check. As we used to do, I will try to start dividing the number using 1 first. We have 13 divided by 1. Our outcome will be 13. So, we have the factors. The first factor is 1, and the next one we have is 13. So as you can see, like I told you, if you divide a number by another number, the outcome that you have, if the outcome you have is a whole number, then that outcome is also a factor of the original number. So that's why I wrote 1 and 13. So if I attempt dividing 13 by 2, because after 1 I'm supposed to put 2, so but I have to check if truly 2 is a factor of 13. So let's attempt that by using this calculator. 13 divided by 2, we have our outcome as 6.5. So now our outcome is not a whole number. So 2 is disqualified. 2 cannot be called a factor of 13. So I will skip 2. I'll move to 3. So let's try 3. 3, 13, 13 divided by 3, divided by 3. As you can see on your screen, you have 4 point. So it's having a decimal part. We have a whole number part, a decimal part. So this is not a whole number. It's a fraction. It's not a whole number. So what we have here is not a whole number. Then we cannot say that 3 is a factor of 13. So let me try another one. After 3, let's choose 4. After 3, we are testing 4 now. 13 divided by 4, our outcome is 3.25. So as long as we have a decimal part, then 4 is not a factor of 13. So if you continue like that, by testing 5, testing 6, testing 7, and so on, you will not get, up to 12. You will not have any one of them to be factor of 13. But if you test 13 itself, like you have on your screen now, you have 13 divided by 13. Okay? Divided by 13. All you have is 1. So this is a whole number. That's a whole number. So in all we are trying to say, or all we have been able to prove, is that 13 has only two factors. 1, all right? It has only two factors. It has only 1 and 13 itself. So therefore, we will refer to 13 as a prime number since it has only two factors. Now, so that's why we have 1 and 13 as the factors, then we refer to 13 as a prime number. So let's go to the next one now. The next one is 16. Okay, next one is 16. So let's confirm what is going on with 16. 16 divided by 1 will give us 16, as you know. So we will write that number here. That's 1 and 16. Let me put it here. 16. Okay, then we that one has been successfully done. Let's test 2. After 1, we make use of 2. So let's go to 2 and test if 2 will be a factor of 16. So we have 16 divided by 2. The outcome is 8. So I'm going to pen down both 2 and 8. I'm going to pen down these 2 and the 8. All right. So we have the factors now, uh, 2, then 8. So if you attempt dividing 16 by 3, that will not it will not be it will not go directly, exactly rather. It will leave a fractional part. Then we or a decimal part. Then if you test 4, okay, let's test 4. Okay, if you attempt dividing 16 by 4, all right, 16 divided by 4, our outcome will be 4. So since we have 4, 4, then I'll just write only 1. I will not repeat 4 twice. So I have 4, all right. So if you attempt 5, of course, 5 is not a factor of 16. 5 cannot go. 6 cannot also go. 7 cannot go. Then the next one after 7 is 8. The 8 is already on our list. Then we know we have 1, 2, 4, 8, 16 as the factors of 16. So in this case, this defies the definition of prime numbers. Okay? As long as we have more than 2 factors for 16, therefore 16 is not. Is not. You can see we have 1, 2, 4, 8, and 16. So therefore, we conclude that 16 is not a factor, a prime number. We conclude that 16 is not a prime number. Right? Let's go to the last one. The last one now we have 17. So by testing, okay, by testing, you have 17. 17 divided by 1, your outcome is 17. And I'll write 1 and 17 as my outcome, as my the factors of 17. Now, if you make attempt of using 2, okay, let's test that with our calculator. Now, if you have 17, okay, divided by 2, you will see that it will give us a decimal number, not a whole number. So can you see we have 8.5. 8.5. So 2 is not a factor of 17. If you test 3, the same thing. If you test 4, the same thing. So therefore, if you test up till 16, okay, they will all not be factor, they will not all be factors of 17, except if you try 17 itself, and you already have 17 on your list. So if you use 17 divided by 17, okay, we obtain 1, and that's a whole number. And so that is where I'm going to stop. You just stop there, and as a matter of fact, we only have two factors for 17, and that is 1 and 17. Okay, we have only two factors, 1 and 17, and therefore we conclude that what 17 is a prime number because it contains only two factors, 1 and 17 itself. Okay, so I think we should stop here for today. We proceed in the next video. I would like you to confirm this, attend these questions that you have on your screen, okay? And let me know your mind or whatever thing you find out in the comment section. Thank you for staying with me. I really appreciate. I'll see you in the next video.